to this. Alright, fine. So, good evening. Nasi class in a rotational motion ki last class hoige dini ka. So, our see nasi class. Kuing rang kai buk to grave da. Easy buk di to grave ka. Duna makata nasi to kai nasi to system toys. Sis kai nasi toys. Talk to screen na kinong to le kanjala ka. Anyway, fine. So, CC question number क्या है जी किधर 3 identical balls का 3 identical balls CC in the last class with me किधर का CC को question number 47 तो grade question number 48 तो grade का now 49 50 51 and then 52 blah blah C theorems of perpendicular and parallel axis theorem ni का CC no yengo the question फजब यावरे येंगे का question number निकन गे Question number 49 for Zabri. See the moment of inertia of a thin uniform rod of mass m and length l about an axis passing through its midpoint and perpendicular to its length is I naught. Its moment of inertia about an axis passing through one of its end and perpendicular to its length l is I ka. So see the noine pan gadu is the parallel axis theorem ni ka. So I naught plus harga l by 2 m into l by 2 whole square the ml square by 4. So option number B is ni ka. Nui sir na hai si follow to bungam bra ma'am. Question number 49 gize B tarne hai ja. Ngam da bra. Kari? Kai hai no. Nui ki makhon ji hum tab pi si kai no. Lakshmi ne wang ang zin ta di. Lakshmi ta bra. Si sin so.
Tayo sir.
Tayo ba. Si prak sumay to so to le. Okay, anyway, fine. So, question number 49 ho to ziare ko adum sir kitang tujan ge na tragadi no gi response ngai among to le sain to gadi ai test ki syllabus se ko cover to the tapa ni duna kitang tujan ge question number 50 sai di sir na kai guma question di tough en khala gadi to ge no gi en tough en khala gadi ko aduga yam lai en khala gadi dum skip to ge ko so question number 54 identical thin rods each of mass m and length l form a square frame. Moment of inertia of this frame about an axis through the center of the square and perpendicular to its plane is an hyperbola. So CGM like na kaino di my center of mass to kedo may the like na L by 2 adu the m harga 4 times of m L by 2 whole square. So adu the kaitarni the is it yes mass m and length L ka adu di magi Kano do moment of inertia do my may I ka m. Do ka road key. Okay. 1 second ka. 1 second. 1 second. Just out for it is. Anyway, fine. So question number question number 50 is in ngamgadra. When a moment of inertia of a rod C kaino have the ml square by 12 ni danaka. Auna azik kaido we have the adugi axis to the parallel or be L by 2 distance lapa amazi putwani aduga 4 ni to torni. No sir na haning is again tabra ta dabra. Nor money to is Question number 50 is ngamgadra ma'am. Sajakumo ID sir na tawzira na traga no ngamgadra.
Tawze sir.
Tawze ba okay tawze. Adu iba target di ay nakalisi sige pace nga ko CD arabi yam daw male. Ano would the target na tadi yara. Tawze ba question number 50 is ka. So sir na pamize kay na matam na noigi critical thinking do. No scientific temperament to adu dusu improve to no beto ko ai sir na kamain khalli have do adu jam na maru weva avdi it's not just about it's not just about the topic which we are discussing right now, but overall in how the thought process the kamaina form to or kamaina khalai have the now sigi question sida si question si noina wakan la na khalaga the answer la ni ko aduga habidi for example sumain road road amaga lere now sida akoina kai kangi am tamda road amazi magi mayaida sumaina si perpendicular axis the moment of inertia zi kaino have the I is equal to ml square by 12 nebo ko aduna kaigumba sida ml square by 12 for gadi ka magi sidagi aina kaigumba my distance si sida kaido we have the suppose aina dot and cross lower zeba ka adudi kaido ziga dot lower sira dot and cross I dot aina tholak paneba plane of the paper they tholak aduni cross haragana plane towards the plane of the paper sangi doineba ana dot ti thole adu sida lay moment of inertia ji kaina the ml square by 12 neba road kido ado sida distance kai lapi have matam na moina small l lapi have na so ke small l orge ka so adu ergadi l by 2 lapeba adu di sida lay moment of inertia adu di kai tane have the ml square by 12 plus mass into distance square di l square by 2 square di 4 adu di si di kai tare have matam da 4 3 12 ka so 3 plus no is again tabra 3 plus 1 is 4 the 4 the ml square by 3 tareba ml square by 3 the mari nina 4 into ml square by 3 kai tawraga 4 by 3 ml square answer is d d tagadamne the no is am tumale no ngor ba gyan tawdra ba sir explain to ke no ngor ga gyan tawdra jigida
sir amta ka hanbiro
hange sir ne sida to isi kai no have the parallel axis theorem pali ne ba ko auna we have the let's say road amas sumain lere sigi axis sida aina sumain rotate to matamda magi moment of inertia zi ml square by 12 neba ada sida rotate to the anywhere aina distance hadi kada we have matamda again yung sigi sida di yung kaina axis sumain action ngam nu ngai roi ba kitang phai ni yek na phado ma le ba ka phai ni yek ke aduga tor ke ka sir phai ni yek tor ke adun gyan tar ni to ka let's say axis se phai ni ke kan gi ba ge si kitu kamai ke kan gi na anyway sigi sida kai gumba aina sikta kan budu road se sumai phai ne le si axis sida ka sida magi moment of inertia si kai ne ba sida le bi si ml square by 12 ne ba now sida gi aina sigi axis sida parallel oi ba and my distance na l by 2 la pa gadi sida le ba moment of inertia du di I dash du di kai oi ni have da ngasai ICM do ml square by 12 to adu the kai total mass and distance square so l by 2 whole square so c the kai tare have the ml square harga 1 by 12 plus 1 by 4 adu the ml square harga of the LCM the kai no 3 plus 1 4 so 4 by 12 adu the kai tare ni have the 3 sorry 1 by keduba 1 by 3 ml square tareba sisi gyan tabra sigi I dash 1 by 3 ml square tare is ngawbra gyan tabra
ngaw de sa gyan tay
okay fine very good so adu ibita argadi akoina kedoni have the sigi 1 by 3 duneba 1 by 3 ml square do magi side mari leibanina sida leiba total moment of inertia do discern always have the moment of inertia is scalar quantity ne duna we can just add the four kedoba moment of inertia side gadra ka then scalar ni direct sum to godine ba and amma khatangi oina let's say kedo we have the a okay let's say this is a this is b this is c and this is d C BC na maram orga laiba moment of inertia due to this BC. Again, BC road sinani ko axis T center da ni ko. Abi BC gi maram orga laiba moment of inertia C sineba. Aduna all four gidi total gidi kai na abda 4 times of moment of inertia of BC neba ko. Adu gi wari ni da. Adu hazik no gyan tabra tadabra khang di ni to is. Gyan tabangam bro. Asito is
ngam ne sir
bra.
ngaw de
So this is equal to the 4 by 3 m L square. That's it. Ka adumaina legaduini. Lakshmi kyan tahobra?
Tahoe, sir.
Okay, fine. Nikhil, say the boss.
Tahoe.
Okay. Amarjit tarba.
Okay.
Okay, fine. Okay, fine. So, sir na sir na pambasi amarum daragadi ka nai fazana nai hana dagi hayrakwa it doesn't matter to me. But nai thawai yawa sincere oiba and kedo hining bro shoto wodo adudu ni yamna maru orisi ka adum masa matanda hayra domne haiba hining ai thawai bi yawardi ka. So let's move on. Surge time is kitang shortage lay aduna question aina yam line kai khalaga dem skip to thoke. So question number 51, a thin rod of length L and mass M is bent at its midpoint into two halves so that the angle between them is 90 degrees. The moment of inertia of the bent rod about an axis passing through the bending point and perpendicular to the plane defined by two halves of the rod. Again, it's a very simple one. I hint of pura na skip to zero hero. Question number 51.
Can PV roll, sir.
In P over ka. Okay. I'm all right. PV. Now, CGC we have that sumaino in a kalobuka. Let's say sumaina maleni and then sumaina maleni buka. Now, Magi wrote total length L neva on a Sigi. She sees the Mazi Dochi the accessory the labor moment of inertia put over the nebuka. I do regard see the labor moment of inertia do the kaino hamatam da M harga L square gimohutta. Sige length L by 2 whole square lani divided by 12 ka aduna adugi potu amuka sida laiba moment of inertia sidi kaino habada M harga L square by 12 into 4 di 48 plus M harga L by 4 whole square aduraga di ML square common lorga 1 by 48 plus 1 by 16 aduraga di ML square lorga 16 348 nina 4 by 48 t 1 by kaidoba 12 tareba ko aduna 1 by 12 to the 2 into 1 by 12 to 1 by 6 tare on ML square by 6 tare man answer sa ngawra jikida ngasai gidu
Sir.
ngawdia okay ngasai gidu ga manay ko so si ML square by kaitani have the 12 tareba ko aduna chisina I harga side amakatangi I1 neba I is equal to 2 times of I1 kind of suppose let's say C is number more 2 times of I1 of the 2 into harga ML square by 12 which is equal to ML square by 6 Nuita sing na ne gyanta dragadi ta de haro sir dum explain to wekem kai de ko gyanta de ta de hagidam amtang explain to zira
No.
Okay, fine. So, asida to isi kaino have the akoina sigi roads in total roads length L neba. Adubu hauzik aina tangkhai de to the ni L by 2 kadang sang neba sije. Ka aduga somgi ju kai kadang sang ni L by 2 dang sang neba. Aseng wo total ji sang na le mi neba. Sang na ka length L or le mi neba. Si total length L neba. Adu tangkhai den maji faina quinty and high grade. Now, it doesn't matter 90 degrees the take care of theory. Kuna Sigi angles is the method of the Sigi wrote Sigi moment of inertia maya the legs ML square by 12 never. So Magi link to the L by 2 is a gramina M L by 2 whole square by 12 la never. Now adugi moment of inertia do Sigi part Sigi katang niko Makai part Sigi and Uranova have the C part in Atang Kaluranova, Sida Katang Kalova. I do the ML square by 12. I do the Sigi Sida moment of inertia do the parallel axis from Palaga. Aina kaitani have the ML square by whatever CGC 48 tarni na 2 square 4 into 12 to 48. Auna plus harga entire mass. Oh, I is square lale. Sitaroi answer sitaroi ko. no explain to kan answer si taram taram tiu suna taro kai no have the mass m na treva mass m by 2 oiduneba aine gyan tabra ai si jong si no aduna ne question hanjun jo holai do ko this mass has to be m by 2 adu m by k 48 into 2 di kai 96 tar ba as pazai audi m by 96 putai ne chumbro into is chumida 96 okay m by 96 plus amazizu m by 2 oidune ba sije m by 2 oidune ba ko aduna m by 2 harga l square by 4 or nina 16 to the 32 oigada 16 ni mo to sije 32 oigada ba ko so this is 1 by 32 oigada ba adu regadi interview soe auna 96 ka 32 ga gi ke doba LCM toro audi na kaina lobi 4 na dum low ro ko 4 na lobi abra yes 4 to 8 4 4 16 8 4 32 8 na low ro 8 3 24 8 1 8 ko so 4 3 12 and 12 into 80 canos 12 into 8 natra 72 ra 4 3 12 into sorry 96 ni okay 32 na ko 32 na direct 3 into to with the 96 tai ko chumine 96 star ni adu regadi 3 plus 1 4 by 96 star ni ko ACC LCM 96 tai I'm sorry si yung kanaudre LCM 96 tai adu na 4 by 96 star adu regadi 414 adu 428 and 4416 so CC 24 tare ko aduna ml square by 24 into 2 the ml square by 12 hai tare ml square by 12 option number D tabram tiyo tai ka kai you know matam sir na mass se si lahodre half khatang ne hedi total mass is m ne ba tangkai khatang di m by 2 ni dana ine m by 2 lahodra ba tare ka adugin auna sida pali ji keno ne ba ko parallel axis theorem ne ba habadi sida lay moment of inertia do di my central mass lay moment of inertia plus entire mass of this part and the distance between the two axes to ne ba ko on the distance between the two axes the l by 2 gi amuk tangkai loksela di l by 4 dang lapani dana sida in si pose di sidi l by 4 lapani ba ko aduna ada inter hot pane ba sigis now gyan ta dabra taraba tadei dum hayo kan ge Amarjit tarbo Saitavos tarba
Tai sir.
Okay, fine. Nikhil tarba Nikhil's library libra sir. Okay, so we don't have much time. Let's move on. Question number 51. Question number 52. The moment of inertia of a uniform circular disk of radius r and mass m about an axis touching the disk at its diameter and normal to this CD my standard formula dunika. Touching the disk at its diameter and normal to the disk. Sarna ngarang formula mari p give do. The kaina matam the disk di ml square by 2 ni perpendicular hebra. Touching the disk at its diameter and normal, yes. Okay, fine. Now the ml square by 2 plus ml square is 3 by 2 ml square mr square tare. Option number D tare ni ka. So 53. No hezikito. Gyan tauda di ta de sir. Dum hero ka. 53. The ratio of the radii of gyration of a circular disk about its tangential axis now, see question number 53 is lie knowing gadrang moidrahin piro ra kaino hero. I know. Question number 53, 54, 55 yengo ka. Two na yengo sasat yengo sasat hero. We don't have much time. 53 am lairi radius of gyration putho aduga ratio logtho habdi divide tawnaroba 54 sina the moment of inertia with disk of mass m and radius r, which is tangential to again it's so simple. A moment of inertia of a uniform circular disc about a diameter is about a diameter is this one perpendicular to its plane. So CD line lie in a perpendicular system pang adam ne ka. So question number 53, 54, 55 si sir skip to thoge natraga noi na tawning ba yaw ga di hairo. Christina tawning ba yaw bra 53, 54, 55 se
53 ge tawse adu ani sidi yarni
53 is radius of gyration putho yen dini.
du mawong do amta
Mong do ka okay taws. The ratio of the radii of gyration of a circular disc about a tangential axis in the plane of the disc. Now, see this key plane of the disc is have the ml square by 4 nidana. Noi khangbra sigiza. Khangiko. Adu about a tangential I do have the ml square by 4 plus m so mr square by 4 have a ka adu plus mr square tani adu 5 by 4 mr square tani. And the magi radius of gyration have the root 5 by 2 r tani divided by n of a circular ring of same radius and mass about the tangential axis in the plane of the ring. Kaigumasi this natari ring or magadi ring gidi kaina have the ml square by 2 ni aduna sida laibadudi kai tarne have the r haigadam ni se ko the mr square by 2 plus mr square adu 3 by 2 ni on root 3 again root 3 by CD root 2 tani r ka kre aduga root 2 si mathakta layamnina makhakta root 5 by root 6 tare. So option number C tare. Ngaubra gyan tadabra tadadi explain tawduni Christina hayo seng na gyan tabra tadabra
tare sir sum mawong do yeng tawba
yare ko seng ko
sir
okay fine atay di loin gyan tahobra Lakshmi tahobra
tahawe sir
Saitabos Amarjit tahobra
Tahu sir.
okay yeah I can't do that. Okay fine, let's move on to the next question. Okay, so kinematics of rotational motion and about a fixed axis. So a wheel has angular acceleration of this and an initial angular speed of this in a time of 2 seconds. It has rotated through an angle, blah blah. See the kinematic question palo ka aduga toro. So kaino mo pyramid have the alpha pyramid acceleration do, then angular speed initial omega naught pyramid times pyramid aduga theta puthuaiba adudi theta is equal to omega naught t plus half alpha t square adu pala holo ko haigadra yadra sir what sira sajainaro kanam kumoktre noi khumdaba tawnu sir what sira yadra kaigino kam kumokti jiba
Sir, habitan hosi.
habitang hot sa okay. So kuina kai khangi amatamda theta puthuaim theta is equal to omega naught t plus half alpha t square. Sir, CD kaino amko thengnadri khalagadi s is equal to ut plus half at square. CD thengnadi hayaro ko kinematic equation duni ko into chapmane ko kinematic equation duni amazina sina translational motion gi sina rotational motion gi ko sir je energy je ngarang de ngasi no hen down sakre nahan ga ngasi ga je khwai down ngarang no di kitang phai wa ba. Anyway, fine. So omega naught, what is omega naught? Omega naught is 2 radian per second, and time is again 2 seconds, plus half into alpha is 3, SI unit pyramid, and then 2 square. ꯑꯗꯨ ꯑꯣꯏꯔꯒꯗꯤ 2 into 2 ꯗꯤ 4 plus 2 2 ꯀꯛꯈ꯭ꯔꯗꯤ 6 ꯑꯗꯨ ꯑꯣꯏꯔꯗꯤ ꯀꯩ ꯇꯥꯔꯦ 10. So option number 10 is the right answer. ꯌꯥꯔꯦꯀꯣ?
Yes, sir.
So question number 57, dynamics of rotational motion and about a fixed axis. A solid cylinder mass 2 kg in radius portion is rotating about its axis at the rate of this. The torque required to stop it after 2 pi revolution is, and I have a question. It's a very simple question. Noida 2019 की मतुंगी question यारोगदी photo फजना हना चुमना फाइदा बिदा चेप्ता बिदा का चुमना कापा थारो सर solve तौरके का. So adum yengon nagi PYQ de yengon question sigi de hena letter version naigadra ka letter years ki question yar thazulo do 57 58 si keno 57 ji yam di lai adu noi ngamni ngamoi henero 57 kana हमको मत Christina khumge tawjaram mane mic on toramaga Christina
तौजे
tawjara
सर
tawjara
होय सर तौजे.
okay so solid cylinder of mass 2 kg and radius 4 centimeter is rotating about its axis at the rate of 3 revolutions per minute and I have a car. So mangunda si the pyramidi kaino hamatamda magi moment of inertia pyramid. Moment of inertia of a solid cylinder di kaino mr square by 2 neva ka. So m di kaino 2 r square di kaino 4 di 16 into 10 to the power minus 4. Kaino 10 to the power minus 2 do square to the 10 to the power minus 4 la neva ka. So mr square by 2 mr square by 2 the 16 into 10 to the power minus 10 to the power minus 4 tire solid cylinder ka rotating about its axis at this revolutions per minute haragadi kaino have the this is angular velocity ni omega pyramid omega si kaino have the 3 see 3 revolutions right 3 into 2 pi ka have every revolution the 2 pi level 3 into 2 pi radians divided by 60 tare ka. So there have the pi by 10 tare, pi by 10 haraga radian per second tare. The torque required to stop it after 2 pi revolutions. Theta zu pyramid theta ji kaino have the 2 pi haraga amuka every revolution kudingi 2 pi levenina 2 pi into 2 pi hetare ka which is equal to 4 pi square radians. Adudi mana putho haisi kaino have the moment of inertia pyramid adagi kedova initial angular velocity pyramid final angular velocity 0 tare aduna kedoni have the alpha putho ani ko alpha du khangadi I alpha di 2 oiduneva. So how do you find the alpha? Now cc da noina kedowi ha matam da v is equal to u plus at dagi panbe abra v is equal to u plus at khanguna tra khangi ko again t yaubra t yaubunina koi t yaudo formula in khanasi so v square is equal to u square minus twice as v square is 0 square minus u square d omega square 0 square is equal to omega square just 1 second ka okay fine so yes sorry all right so taurasi makha taurasi ka noi dum sarna kai taurakadoino habdu dum khangwa ngamani sidagidi natra okay v square is equal to kaino u square plus twice as natra so plus 2 times into alpha into theta yare ka sim ta height to screen le in khanjala leger makha gi adu regadi aina kai tawba alpha puthokninge adu di minus sarga omega square omega di kaino pi square by 100 aduga kaidoba 2 theta na yengadoiba makhada adudi 2 lerani and then theta di kaino theta di 4 pi square adudi pi square ka kreka fazaine to izeka omega square z sile adurugadi kaitane have the 4 2 is 8 ka so which is equal to minus 1 by 800 radian per second square nebuka aduna as I have alpha then talk the I alpha nebuka on I di have the 16 into 10 to the power minus 4 into again cc alpha ni now minus sign sino low drazu 1 by 800 toro adu oiba taraga di 8 to 16 so which is equal to 2 into 10 to the power minus 6 tare 2 into 10 power minus 6 ka. So option number B is the right answer. Ngao bagyan ta hodro zikita. Tai ka. Christina ta horrible.
Tahore sir.
Yare ka. So everything is in kedoba SI unit never sir no is ka. Then you can just put Newton meter. Now let's move on. Question number 58. 3 objects, a solid sphere, it is circular disc and have the same mass, radius. They all spin the same with the same angular speed omega about their own symmetry axis. The amount of work required to bring them to rest would satisfy the relation. And so it's a very simple question. They have the same mass and same radius. So which one have the largest radius of gyration? Radius of gyration quite chawduna moment of inertia quite chawduni ko. And moment of kari
T na chawduiba. Answer je A oiduna drop.
Obviously ring na quite na 1 ko. They all spin the same angular speed required to bring the amounts of work required to bring them to rest would be have a cost. So C is na quite yes. So WC na quite chawd the A tarne option yes. A is the right answer ko. Very good, very good. Ring na quite here have the sir na ko moment of inertia. Loina magtagi ko. So mayam lang gyan ta obra.
sir.
Okay, fine. So kano to ba Lakshmi kano di nangi kano di Lakshmi ki friend di yaukti kay gino.
Mada si chapter ki oina di yarani haiba mal.
Oh, yeah. Okay. Fare. So question number 59. A rope is one around a hollow cylinder of mass 3 kg and radius 40 cm. What is the angular acceleration of the cylinder if the rope is pulled with a force of this? So force P then radius P so R cross F C torque ni ko. Now, what is the angular acceleration? So angular acceleration di have the I alpha is equal to torque. Harga torque to the magi I ni laga alpha dum thola ni ko. Now CC sir na brang budi hydrocrane no gyan ta hobra. Sob tawd dusu yadra. Sajakum naro. Tanam kumaptre. Question number 59, 60 is a paro. 59 ji ngam gadra ngam medra sajai na ro.
Adum tawbiyo ne.
Adum taw se ka 59 sa. Okay, fine. So, question number 59 yung asika. A rope is one around a hollow cylinder of mass 3 kg and radius, blah blah. So magi moment of inertia is have the m hollow cylinder in ko. It will be simply mr square. So 3 into 4 is 16. 16 harga into again C16 katang higher su budi yare kaino di suppose 1600 higher ni 40 square di ko into harga again 10 to the power minus kedo ba 4 la ni centimeter ni meter ni na ko 10 to the power minus 4 la ni aduna adu bitaraga di kaitani ha matamda 0. Kedo ba 3 sina ko 16 3 di 48 ne ko on 0.48 tar magi kenos moment of inertia is ko. Now aduga kaidoba, what is the angular acceleration of the cylinder if the rope is pulled? Now torque puto torque ti kaino r cross f ne rf sin theta ne ko na rf sin 90 degree d 1 ina rf tar. So what is r? Ai si kaino hai ge ko no yung si ngau da na formula ma iram ge. mr square ne ko. So rf, so what is r? R is 40 by 100. And what is f? F is 30, so cck, cck. So this is 4312. Now, alpha is equal to torque by I, which is equal to 12 by 0.48, which is equal to 1200 by 48. So 12,448, so 25. Now 25 the chumme ado my unit to kayo dinu na have nebuka. Now torque ki unit C kaino have the radian per second square oiroi. Again. What is the angular acceleration have? Okay, angular acceleration radian per second square do. Gyan tau da bra. Yar bom yam.
Yare, sir.
Yes, sir.
Yare ka. So it's a very simple question ka. Sumaina khan batam mo ba? Abadi kaino hamatam da noi again si kaino hai ni ka. Kari sin kaino sir kaino tang hai ge ka. 1 second. I won't post the recording call. I just want to share you. I share something. Sir, screen chow na tholak pra. Sir, screen chow na tholak pra.
Board adum ure.
Board adum uri ba. Yeah. Adu oiragadi aina zik si share screen. Board adum uri ba ko adu di si toragadi. Yar ba zik ya chow thola ba.
Thore, sir.
Okay, fine. So keno hai ge. Sisi tau ba ko. Everyone, each one of us, sir, so tawi no is going to ramniko and tohan be I see the program to be learning helplessness syndrome I get raka. Again, sisi psychological kahene queen class psychology class hai tare ko experiment to be ai ba. Suppose class sida kedo ya matam na nui class sida ne sir na test am law ba. Test sida question paper set A set B khai do ba. Nakan nama da pham nakan nama da na set A loin tha le nakan nama na set B loin tha le ba. Set A da na aina question ji khara live nga ta hange ba yam live ba. Set B da na yam lu ba nga ta hange ba. Ado noi da hai dok te ba ko sir na ni khudimak di kedo question paper ji amana set A ni amana set B ni ado som nakan set A ni som nakan set B ni je hai dok te ba. Auna kedo we have matam da set A phang mi du di ai answer tare no harakani ba. Aduga set B kangbu du na di kedo we have the mina sum tagi ba natraga kahani adoin tawsala ko isaji thakalaga ko learning helplessness na isaji kedo ni have the tasing na question du even solve to we ya da question ba adumain design tawraga hapam bagi hedi adoin hap to ne ba si keno ji da ko thor keno ji da id si psychological experiment ji da tare auna si experiment ji da kaido wi amatam da wakan je koin henjana khanjan grani ba aduga ai ji isana isaji kedo ba wakan khan bangam dre demotivated or ne ba learning helplessness sai je ko sumaina auna sarna si gi ji noida ji hari ji kai gina da noina ji question ko rotational motion वगैरह मोगेरा physics की question वगैरह chemistry की वगैरह bio की वगैरह any question kedo wi amatam da noise noigi schooling hai gadra noigi tuition hai gadra noigi oja sing ama anything tawrko matam da kaido ya satra kharana haira la ane and satra kharana hayoroi ba and just in case haitaba satra marak tu noi yawren khala jeba noi na sana sai stupid feel tawrane ba I'm so stupid anaka moina hai aidi haite na then au they learning helplessness tam na mind hapsala ne ba aidi haite na ado taseng na kaido we ha matam da there is no such thing ko abidi no exisar na dum higher kan no dum gyan taram ne ba so ain to na ai na khatangi wana te anyone kana nom na फजन नोइदसु ए सिनी स्वाइन हायर फन लाखपर नोइ कॉन्फिडेंस ओइना दम बिल्ड तौरगा ए हैनी इन तौरगा उदगी नोइ क्वेश्चन जी फेस तौबदा कॉन्फिडेंस याम लैना हाइतारे फने टफ ओइबो क्वेश्चन ओरगाजु नोइना खनबम थोकपा चांगदो अदु खलकदबनेबा अदु खनबा ngamdisi learning helplessness ana ama leibagi nebako aduna yarige adu potu lehendanaba taw aduna kedawi have the hazing matam dadi kedawi noina anything kenom khangdab the one click away ni ko internet and noi tum answer thige zum phangani natragana anything related to kedawa physics ki orgadi certain approach lok pa yare and atopa subject ki junai concern teacher noina khachana ba nungaiba ojadom hango aduga ngasagi we have the no yam kuina haitare schooling dagi or tuition dagi kai dagi learning helplessness dum noi da hapchal la am ni ko induce to la ko ni na question je ngamaroi du the ning bodo this is beyond my scope of understanding I get beyond my capacity I get adu maina khal ga chat kal le ko and si adum tawi tawju dum taw duni haji angang sing 11 12 kariba then no gi bachelor blah blah or anything college graduation masters blah blah doesn't matter learning helplessness any age any section any group that haitare dum induced of way so learning helplessness se nasana isana khangjo ko haidi ai learning helplessness ki trap the fall tore and ai siji asigum kem leibanate aina phajana dum kedawi have the na kahani wakhando always kedawa nangna khangninga gadim thi dum phangani ko aduga isana stupefied oijabado as I'm so stupid and khanjabado kaino mangam dabagi so adumain khanganu ko anyway sir naning gyan tarona sir na taptai ngangsen
Sai sir.
yan ken ta haidi sir na haije haji yong sir na torakan yam lai draba question jingdo now si yam lai ji kaino have noida amukai si gi same question ji hayeng on noi ta ke noi taning noi si rai lai si khangena khangdaba mi amaga khangdaba mi suppose tangkhayam phamaleba nadu noi am phameba adi khangdaba kangbu dundi ke done we are so stupid and khangi duineba noi na moi di khange moi di yam thina smart oi moi di yam phai id yam kayane id yam sibo khangba ngamde kana adai to learning helplessness keno to hon ge duineba id kedawa learning helplessness syndrome hai ga si lehen ga duineba ko induced to duineba so si phatte isana isa ji learning helplessness ki keno to the trap to the fall to haloi damni ko anyway let's proceed question number 60 the haji keno a uniform circular disc of radius 50 cm address is free to turn about an axis which is perpendicular to its plane and passes through its center. It is subjected to a torque which produces a constant angular acceleration of this. Its net acceleration in meter per second square at the end of again sigi question je paro yam lai data loin suno ba piram me moino puthuai is net acceleration puthuai bani ko at the end of 2 second so ngamgadra ngamoidra hairo again no anything any question am pa matam da piram iba data si kai no hana khangada first thing then mathang da kaino puthokadu je ko or adum kaino puthokadu je and adu puthokuda changada data ga si yaubra yaudabra adune yengduje so the p is kaino net acceleration puthoiba so acceleration puthoke hargadi kaino nang to tagi putho su yare na tragana moment of inertia haidi to divided by moment of inertia si acceleration ni ka angular gi aduga ngasai force lom da yeng force by mass har su yare ka whatever so see that a uniform circular disc of radius 50 cm address is free to aduna mazi mass adu da toroi mazi tedoba torque by moment of inertia torni so my radius pyramid and then magi it is subjected to a torque which produces a constant angular acceleration of this okay my angular acceleration pyramid ka aduga torque ti pirambra torque ti piram devu ka so okay anyway net acceleration is and have a now magi unit c ke dawi net acceleration unit piram de kano katang value katang piram so cc sir dum tawzira sir na dum tawna phagadra sada hainaro
tawje sir
tawzeba ka tars Alright, go. Yeah. Alright, okay, so yeah. Go. So, alright. So, solve is a uniform circular disc of radius 50 centimeter. Disc never radius 50 centimeter labor is free to turn about an axis which is perpendicular to its plane and passes through its center. It is subjected to a torque which produces a constant angular acceleration of 2 radians per second. So my R pyramid and then magi alpha pyramid. Net acceleration in meter per second at the end of 2 seconds t is pyramid. Aduga kainu putwaise. Its net acceleration putwaise. In meter per second. Its net acceleration in meter per second have a call. Okay, fine. So aduragadi moi putwaise in meter per second haragadi cz putwaise never. A is putwaise never call. Aduragadi thoidokna sida kaino tawninga yaude. Auna akoina kai khangi hamatamda v is equal to omega r. A small r in sinarge loin small nga taina ko. Adurdi a is equal to alpha r. Ka. Okay, fine. Constant angular acceleration. Okay, so a is 2, r again 5. So circular disc haibagi kari kano lairigi si the question is the let's think about it. Perpendicular axis have an passes through its center. It's subject to a torque. Magi mass ikathanarga. Now kaigamba my moment of inertia is a circular disc in mr square by 2 never. Duga subjected to a torque t I alpha. So I alpha is equal to mr square by 2 into alpha again. Constant angular acceleration 2 never ka 2 ka mr square I alpha zika. That is the torque. Torque se mr square tar. Torque tagi aina kedawa. My moment of inertia no yen ba. I no yen ba. Mr square by 2 tar. So that the alpha is ni masai 2 laser. Okay, fine. Since we address of the was a topa method kai lay to ying si alpha is 2 ni r zina kya no r zina 50 ni. So 50z 5 into 2 the 10 so 1 jong yaw de ko. So question z queen and decode the server net acceleration in meter per second at the end of 2 seconds. At the end of 2 seconds times pyramid ko. Aduga net acceleration hamne constant angular acceleration harga net acceleration putho haisine ko. Kai the story no have the net acceleration is equal to a omega plus under the 2 plus nasai alpha is again 2 plus 1 is 3 ta dong ma answer is 3 ta bram te one question ki tang di ke no answer 3 ta bra me am ti one
Biết ơi người ta sir.
Okay, durga kai so no with the main command so no durga ka 1 second. Where is it? So it is question option number C je tai hai ra.
Oi, sir. Chi chạy, sir.
Okay, ngay ko ka. No. 1 second, 1 second. Kadai degi kamay to sway no jikita. Easy never ka. All right. Okay, okay. So do avatar gadi ina kadai de sway. Ito never ko yeng to sa. Oh no. Tenje I know to is it initial acceleration di 1 tare dana ka. Duga magi nasay alpha dun 2 1 plus 2 di 3 tare na hai bane ka. Duna acceleration zika. My net acceleration zika no sinaka. Durability at the end of 2 seconds have never. No. So V is equal to V plus AT. Okay, fine. So the yang si ka mo gisa. Aw na. Siguro kano si question si no kano option gadam ni ka. Kitang section gadam ni si question si matik tok sa lo ka. Sida data di myam le du answer se fractal atan ka. The answer is yang si kamay let's explore the various options available. Mo net acceleration putwo hai ka. Disk kama layer me aduga masi magi perpendicular axis ka amada rotate tawre and then magi sigi radius rz 50 centimeter ni 50 by 100 or 0.5 meter tare ka ana 0.5 meter ni radius si aduga it is subjected to a torque which produces a constant angular acceleration alpha z to radian per second pyram में aduga times in a 2 second pyram में radius in a 0.5 meter pyram में a putro हमने ba. All right, fine. So अखिने कई खंगे have the v is equal to omega r. Yes, v equal. Okay, so very good. Aina a is equal to harga alpha r lan hai dv by dt to got differentiate to matamda. So which is equal to 2 into harga 0.5 ne, which is equal to 1 ne ba 1 meter per second itare ba. Sisina tangential acceleration ne ba at ne ba. Now AC centripetal acceleration d kaino have the omega square r ne ba. And omega square d 2 square into 0.5 ne ba. Or the 4 522 again 2 dum ta draw omega square or is it nati omega 2 nati alpha ne 2 di ko omega di piram de ko maina omega di kamai puthokani have the omega piram ro maina piram de is at rest have ko okay yeah is at rest I mean 0 de le ni omega di omega not have the queen of v is equal to u plus at laidana omega not plus alpha t whole square times r or ni because then omega not is 0 plus alpha di 2 lere into 2 among lere duga whole square into radius ina 0.5 lere adu regadi 4 the 16 into 1 by 2 lere adu di 8 tai ni ka centripetal acceleration ina 8 tawa yes kay you know centripetal acceleration with the 8 tai ka aduna pot si kaino have the net acceleration in meter per second at the end of 2 seconds at the end of 2 seconds hamina si join lower ni koina ka omega not 0 ni have the kaino have matam da rest layer me at rest ka and my alpha pyramid my time ji pirame aduna omega square r ne ba akoina circular motion gi uniform circular motion da tawgi bodo anything which moves in a circular motion will be subjected to some centripetal acceleration, and the centripetal acceleration is given by v square by r or omega square r. So nana v dudi akoina kaidawi the khangde khangdabnina adom da putoktabe omega square r dum putoji, so omega dudi sumain lere, and then r, so 2 into 2 4 4 4 16 16 into half t 1 by 8 sorry 16 into half t kay tare 8 tare ba. So sumain toraga 8 tarni sir c 8 plus 1 9 taroidran hai ba noina da khang adan khallagadi sigi si akoina kaido we have da sida kaigumba mass akoina kaigumba my tangential khatang ni yengagadi my acceleration do at do that is 1 eba ko aduga magi overall oibududi kaina have the centripetal acceleration overall oidine net acceleration hamina noina always khanggadabsi circular motion the net acceleration haragadi centripetal acceleration do oini ba. So centripetal acceleration do di sigi omega square r se pale aduga 8 tarak pa ko mayam gyan ta hobra sir explain to ija
sir.
emergent matang kumai ji kaino lakshmi ta Christina tatlura dai ta hobra
sir khara taur.
okay fine say to boss Nikhil
Sir.
Amarjit tareka Esther star ba tareka. Okay fine, let's move on to the next question then. Question number kaya tawjige matang da question number 58 ka. So question number 58 nati 58 nati question number 60 na tokon jitay da question number yung adudi question number 61 je yung ka point masses m1 and m2 are placed at the opposite ends of a rigid rod of length L and negligible mass. The rod is to be set rotating about an axis perpendicular to it. The position of point P on this rod through which the axis should pass so that the work required to set the rod rotating with angular velocity omega naught is minimum is given by blah blah blah. Simi antoring ngarom mani gyan tarmara. Sida hangningi si kaino habda the position of point P on this rod through which the axis should pass so that the work required to set the rod rotating with angular velocity omega naught is minimum. So isam na habda magi kedoba magi rotation thokpa matam the minimum ohen gyaragadi akoi axis of rotation ji kai de lehni center of mass lehni buko isam center of mass putwaimni m1 ge m2 ge center of mass putwaiba yarba ya de yeah ko adudi kai tarne m1 into 0 plus m2 into L by m1 plus m2 m2 into L by m1 plus f2. Option number B tabre yengo tai ko so see question ni pa blah 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 ma'am yaw yang center mass ne am putwais. So question number 62 ko 62 yengo and automobile moves on a road with speed of this, the radius of its wheel is this, and the moment of inertia of the wheel about blah blah is this. If the vehicle is brought to rest in 15 seconds, the magnitude of average torque transmitted by its brakes to the wheel is an have a car. So duragadi magi kedo we have the tangential velocity pyramid radius pyramid the angular velocity khangani angular velocity do initial angular velocity pyramid moment of inertia pyramid time pyramid final do the zero ni aduna kai phangani have the isam ne omega si initial angular velocity omega naught chi moi pyramid ko v dei puthoni v ga r ga dagi omega puthoni adugi omega do sizinaraga and time sizinaraga final angular velocity zero ni aduna angular acceleration khangani adugi angular acceleration duga magi moment of inertia duga into tawraga torque tarani kaine torque si I alpha ne natra yadra yani yaro ingam ningam mosa hainaro Tauzira tauroizira.
Tause, sir.
Tauze. Okay. Sir, question khudingi taudori tauze. Tauze ka. Sidi no ngamni si am live question. So kena kai pame omega pame. Omega di kena v by r. B is equal to omega r natra. So v by r. So v di kena b di 54 kilometer per hour. So my kilometer kg kilometer geometer on top of the 54 into 1000 divided by 60 into 60 into radius di kya no 1 by 0.45. Now 0.45 to 45 hai ka 45 by 100 hai. So c 0 ani so z 0 ani ka 9 ka di 9 5 45 9 6 54 6 ka 6 ka crop. Audi kai tare 6 5 30. So there is 100 by 3 tare. This is omega. Now my mass pyramid. So I put was it. I is again a wheel. Wheel is the moment of inertia of the wheel about its axis of rotation. So wheel is equal to ring nin log with a disc nin log with the hyper cushion numal lay. So let's just take it as ring mr square. So 3 into r the 0.45 45 by 100 So masidi into tau later 5 na tau gudra 520 59 59 520 3 ni goes yeah. So Durgadi 9981 313 83 24 243 by 224 100 400 tar. This is I. Kai putok ba? Alpha putok wali. So alpha di no acceleration di have the final velocity 0 minus initial velocity di 100 by 3 divided by t 15. Adi kai tara minus 100 by 45. Adu ergadi kai no mai putoy tau tok putoy ba tok ti kai no tok ti I alpha di kai no 243 by 100 into minus 100 by 45. See on tono ai da 243 3 ne ka gya bra yeah 3 8 24 313 and 3 1 3 3 5 15 9 again 3 ne ka pe. So 3 to 6 got 7 3 21 3 5 15.
Sir, I'm at 43 by 400. Oh, the one.
Oh, this
Moment of
okay. This is 243 by 400 la. Ha, manika. Okay, fine. Yeah. Chumi. 243 by 400. Adu edi kai yoji kita. 5 see the forum labra. So 5 4 20 27 by 20. Ka 27 by 20 dar. Do ergadi 27 by 20 already 1 point something tani ne 10.86. Moizibo 10.86 tabra. I'm thinking.
Option C होए
Option C होएगा 6.66 star है बता दे जो है गद्दी कमाएगा काय दिस होएगा alpha दिस होएगा toxic I alpha mr square नहीं दोनों m into r square r square mr square 243 by 400 no dum yai kem kai de so alpha is in 100 by 45 si du kem kai de I alpha natra okay kakna bu the soibram je yong ka 400 ka 104 450 20 ne ko and 27 what the 27 ta ba kai no 3 into 15 45 3 into 81 yes then 3 into 27 3 into 5 so 5 into 4 20 kind of this way 00224 400 and 9327 27 into 3 81 81 into 3 alpha d kind of the final minus initial divided by t so this tab ko sisu lang chumni dur gade kai the sweri ka ba is there any mistake and okay yes so I found a mistake moina ne alpha I is direct 3 in pyramid aina ne 3 kg dang ure si mass when ure adine na mr square kai to ri ka I is direct 3 in pyramid moina gyan ta rise adu gadi I alpha koina henjan na puthore mina direct I is 3 in masana direct picture mam si wai no puthok challe gyan tai ko tabro aduragadi kai tarne 3 into kaidoba minus 100 by 45 so talk to negative for idune ko so 3 into kai tare 15 adudi 15 na 100 taka ka ke ha gadi nang kai to minus 20 tarne duga 3 adudi minus kai no 6.66 tare so option number c tai ha de no ba okay fine so kainogi Christina gi dagi ngai ji keno idura Anjali udra natabra okay haji kidan kaino ni ko Lakshmi ni ko kanam ko motreto is mane ba ko all right fine so anyway okay so yar okay yadra si kise ma'am
Yani sir.
yani ko okay sidi Christina all right yeah atai di setobos yar ba Amarjit Nikhil yare ko okay fine so question number 62 question number 63 a solid cylinder of mass 50 kg and radius 0.5 meters free to rotate about the horizontal axis. A massless string is wound around the cylinder with one end attached to it and the other end hanging freely. Tension in the string required to produce an angular acceleration of 2 revolutions per second is an ham neighbor. Question budi adum fazai 63 su 64 su fazaba mali. So comment to 63 64 se adum pulab ho chehra.
Sir na pula hotraso dum hint kumbado. The diagram kumbado hypet would be ramaga thambiram so dum yai.
Question number 63 is there. Solid cylinder hierarchy. My mass pire, my radius pire, and in a massless string wound around the cylinder with one end attached to it and other end hanging freely. Haziki mangunda akoina talk amala kanibako. So see talk cinemazi rotate or kaduneva. Adugi talk to kailakani hamatamda aziki tension in the string required to produce an angular acceleration of 2 revolutions and hamneva. So sigi tension ji kaino habida ziki aina kedoba ziki aina string du ching du neba adu tension du neba adu force du putho habneba so adu or oibata gadi theta do ko theta do aina se sideng si ko ai ha pe chok ko ma hai ge chok ko ma hai be do man sir budi ta thokren question je ke sham lu question te ko mid thak pi da ba ai ta isa je nungdang ni thenga am ni na mid thak pa or kino to ba rest on ning ko aduna kitang helak pa anyway so minus solid cylinder am lai ko so sigi sida ke do ba swain to ga string ama swaina string ji ke do ba swaina le ai si string da pat launa tension t na pat launa pull to de na tra ma sama yan de na khala ji ko kem kai de adu da sigi po chi rotator ka ne ba now rotator ga angular acceleration ji 2 revolutions per second p ga do ne ba ina alpha is equal to 2 revolutions hai 2 into 2 pi radians per second square p ga do ne ba alpha se au da lai ba to putho u haibane aduda leba force or tension do F is equal to what hangmaneba adu regadi akoina kai khangi ha matamda dai torque ti kaino torque ti R cross F again torque ti amu kaino torque ti I alpha adu regadi noina kaigumba F puthokning bataragadi if you want F adu di kai tare I alpha by R tarba taita de tai ko tabro ta dabro kaino kam khomuk ti jiba
Sorry, sir.
adune adumain putho ba so magi solid cylinder ki moment of inertia di kaino mr square na tra so 50 into 0.5 or gadi 5 by 10 or 25 by 100 hairo mr square le I alpha di kaino alpha di sida le to 2 into 2 pi le then divided by R. What's the radius? Radius di kaino 5 by 10 gore kaino do that. How di sidi kay tarne si si 0 amna si 0 ka crop aduga kay tarni habda mui di pi gam da takti ne ka kaida kay sorry de 22 pi radians per second square. Solid ring yeah. So solid ring the mr square by 2 ne ko half am wala me sida sida. So half say sumai no in half again. Sido in half again ka half to mr square by 2 ka aduga alpha z alpha c 2 revolutions per second and 2 into 2 pi tar ne ko divided by R. Angular acceleration of 2 revolutions per second. Now pi is mango yaroi. Mo is point ga tare ji ina si point di tawaze sungu uru drenga sage. Anyway find yeng as ko dur ga de c5 siga c5 siga kakre adu c2 ji matak ta kakalani 25 into 4d 100 tarni adu di 2 3.14 into 2 y tar. So adu di 2 into 314 tar divided by 10. Is it? No. Si 10 ji ka makai matak yes 2 into 314 tar again. 2 into 314d was economic to have the see okay not the I swear sorry so mind to say baka 314 by 2 have 314 by 2 tar so adur get the 212 2510 then 2714 157 newton tabra untiyo tabra kanam ko magtre
Sorry, sir.
taiko okay so let's move on question number next kido kay tare dudi Question number 64. 64 city. A rod PQ of mass M and length L is hinged at NP. Aduga, the rod is kept horizontal by a massless string tied to point Q, as shown in figure. When string is cut, the initial angular acceleration of the rod is, and I have a call. So again, sigi question si, nui si question jingam gadra start torora. Question si fazay. Start torora ka. Alright, fine ka. Yung si. Alright, so a rod PQ layer of mass M ka. My rod C, smile rod layer ka, and my mass M, and then my weight si kay, so I the actor ni MZ. Ano sida tension kay dawa sida T M layer. Length L sang is hinge at point P. Okay. Oh, sida point P, sida hinge. Sida ka point P. CQ tatlam ni sumay no ma paithara ni makada ka. Okay, fine. Yeah, kem kay de. When string is cut, the initial angular acceleration of the rod is an have. Did my alpha put away alpha. Alright, fine. So, and si tatpa matam na si sumay na paithara ni buka. Do ni sumay paithara patar gadi magi alpha z kay ni na have ni buka. Initial angular acceleration si. Alright. Adu bitar gadi akoy na kay dawi have matam da magi ka. Alpha z kamay puto ni. Alpha haibisi akoina kai khangi habda. What is alpha? Alpha is equal to tau torque by magi moment of inertia neva. Yaiko. So what is tau? And torque to the kaino r cross f neva ka. Alright. So alpha the r cross f ka. So r. Distance r do ka. Distance r do di kaino habda magi length total length L neva ka. Si patlong tatpa matam da magi sida lakadini aduna L by 2 have this sida when actor kani because sitat ki matam da my center of mass actor kani ba that will be equal to sida balance storm ba sida param bane ba ko tadat ki matam da si sida actor kadini ba sida post op na tamina ko. So when the string is cut, the initial angular acceleration of the entire rod have my center of mass from the yin and ko there gadia auna r cross f for the L by 2 into mz pirambra. Yes, piramagumanico. And then my moment of inertia of the rod. Moment of inertia of the rod see ml square by 12 if c axis the rotator with targadi. The c axis the rotator with targadi ml square by 12 plus m harga L by 2 whole square. So adurgadi ml square common lorga 1 by 12 plus 1 by 4. Adurgadi ml square harga c12 tarni ko aduga 4 3 plus 1 4 id kedoba 4 3 12 so 4 by 12 so 1 by 3 ml square by 3 tare so ml square by 3 tare m ga kakre L square ga L ga kakre aduna kedoni have the 3z by 2l tare. Option number C is around 3z by 12. Yengo? Gyan di ta hobra? Okay. Atay di. Asterisk gyan ta hobra? Okay. Amarjit, Christina, Setabos, Nikhil.
sir.
Okay, fine. So let's move on to the next question. Question number 65. The instantaneous angular position of a point on a rotating wheel is given by this equation. The torque on the wheel becomes 0 at and habuka. So ma theta pirame adu ergadi nangna differentiate to matam da angular velocity omega fangani amukka differentiate to matam da angular acceleration fangani aduga magi angular acceleration is 0 or kind of talks 0 is moment of inertia is 0 ya damina ko auna adu 0 oi ana 0 the put option matam the t the put hoga nam tarani sir na haji gan tabra auna 3 2 is 6 t squared is 12 t 12 t lere adu susidana 6 2 is 12 t adu 12 t 12 adu t is equal to 1 second option number A taramni sigis 65 se kai time tiyo Okay, yeah, right. So the question number 66, a uniform rod AB of length L and mass M is free to rotate about point A. The rod is released from rest in the horizontal position. Given that the moment of inertia of the rod about A is this, the initial angular acceleration of the rod will be, and I have never got. So mazi okay, rest again release the rock. Given that the moment of inertia supiramba initial angular acceleration of the rod to kay within free to rotate about point A. Karino mo yung question de gyan tadre. Initial angular acceleration POA kay rest lemadi kay is free to rotate about point A. Rod is released from rest. Rest is released already. Given that the moment of inertia, whatever, blah blah, anything like initial angular acceleration of the rod will be a chikay hay no sigo. Moina haji dimension de putu hairaba. Moment of inertia dagi torque putuani torque ti kamay putu ko deba moi force. Question ji gyan ta de ne. Question gyan ta de. Question number 66 question ji gyan ta de kay hani no khang de. Kitang strange way question number 66 ka. Ni pung ji jo ta thoki ba to 9:38 chat le me to is. Second si question is gyan ta de kay. Yang ji ka. 100 주항에 2007 주항에 and 2006 주항에 trains way. Sida hai ji kaina. Ka from road. Do I miss anything? Okay, fine. So, moi is the amtina berakai. Moi na haning is the diagram ji sumai is kai ngong din. Moi na na sumai na si na tragedy diagram ji lay roiba. Let's say road am sumai lay reba ko. Si road si is the hin story ba. Ang na kaidawni ha matamda nang na si road se. Sumai na haidi CC aina kaigumba CC hek thadokku matam somna kan hek thadokku matam sumaina makhalom da lakani dana gyan tai ko gyan ta dabra road se aina hek thadokku matam da ne sumaina haidaraga maji paitharakani wasigi road se aduga abadi road si sumaina paitharakadoine buko aduduni mam puthuai ji berani jibu si diagram sumai yemnina kanan khangduino aduragadi my mass to disidani ek tobadisi mg ji ko aduna magi angular acceleration alpha putwaiba alpha di always tau by I ni dana ko auna tau du di kaino r cross f r l by 2 r f di kaino f di mg and then I di kaino have the ml square by 12 ngasai gi do ml square by 12 plus mass into l by 2 whole square adu di ngasai gi do ml square by 3 tagida auna sida ml square by 3 tagadabni so adu agadi 3 by 2 mm ka kre l ga l square ka kre aduga 3 by 2 z 3z by 2 l tagadaba ko 3z by 2 l tabrem answer
Tayo, sir.
adu sidi ajikta mamang solve tawgi chamana do kenam toyne 3z by 2l c question si makneba moi solve tawningi c diagram ji gyan taeba si pat thadat pa mutan sumai makhada haidara ka ni ji gyan taeba CD moin the road to CD axis male so main lay do male the kari question ji kamay diagram show e basi ji ko gyan tangam de moin diagrams there are any questions ko anyway for adur gadi question ci id angular momentum in case of rotation about a fixed axis no see me am to loin try to ro sir noida keno toge topic macha amani ka ke ko aduga noina angamba ge solve to hangadeni rolling motion gi topic machet am khak ta ke aduga yeng sika let's do rolling motion qualitative ko noi ngam da question do sir dum tharo sir dum to ge kon ne classroom gi group ta dum tharo sir si question jingam de na ko sir dum to ge ai sir test ki keno ji follow to da ya dam ni no qualitative ko yam ya bro sir na hai ja kay no ka okay all right so let's say sigi body si sidagi roll to thare khalasi ka now mazi magi height si kitoba magi height si at height h ne na khalasi ka let's say height si they low jira let's say this is at a height h ka and let's say my sigi distance let's say this distance is s ka and let's say this is theta aduragadi kaina masi roll down tawrakpa matamda magi we have the acceleration putokpai ka my velocity putokpai si makhaji yokumatamda my final velocity kai waini and then magi time ka so we can find out the net acceleration net time and blah 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 adu mem putokpai so kaina si magi kedoba keno tawzika total energy the pala yengazi so half mv square plus half I omega square ka sige ka mathak sida ka laiduni ka so anyway auna sisi laani adu oi batar gadi kai lakani habda magi si total energy si hazik mathak ta laisi kaino mgh ne ka aduna is equal to harga mgh ana leiba ka so sidagi ina final velocity si puthokpa yare ka kaino di haurakpa matamda di magi kedoni habda sida leiba kinetic energy se translational is equal to 0 and kinetic energy rotational is equal to 0 sida di animak leigadone ba sida di magi only potential energy katang laine ba mgh katang ka aduna aina sida m ka kre sida di I sida keno I gi motai mk square ina sinage ka aduna farni samjan ge ka di sir kai I gi motai mk square hai jabda ai si body ji kai no hangde this or ambe spare or ambe cylinder or ambe or any other object or ambe which can be rolled aduna the kind of flat ti or ya or roll to we have body amne awna magi koi kai no ji khangdamina mk square si the general when hola yodi m ka kre ka adu ergade na v puthoke ergadi kai dawni have the 2g na si tordi 2gh star divided by herga 1 plus k square ka G 2gh star mane ka aina kaigumba b square si common low with the 1 plus half ka half se sum pugre ko v square common lo tar gadi 1 plus k square by omega je amuka kai tarni omega square by v square sumain tarni ko. So aduna aina sigi pot si again this is still v square. The final velocity v is kai tarni have the root over 2gh divided by haraga aina c omega square by v square c v is omega square r square ne ba ko omega square kaktat karga 1 plus haraga k square by r square na ta ba ko. So c noi gyan ta ba ngam si se yengom ta since haraga omega square by v square se b square di omega square r square ne ba omega square kaktat 1 by r square ta ya ngau bra kayino kanam ko mukti se Lakshmi tabra
Howdy, sir.
tadia
Hi, sir. Hi, sir.
tae ko okay fine Saitabos tariba Amarjit tariba
Hi, sir.
Gyandi tabra Gyan tabro okay sida
Yes, sir.
sida to is kaino have total kedoba energy sida leisina mgh neba aduga sida di my total energy si kaino have the magi potential energy si mgh completely kaide convert to grani have the translational kinetic energy and rotational kinetic energy any do convert to grani ko adu the level my velocity putho have neba so c velocity vj in my putho ko matang da kai putok sige let's find out the acceleration ko aduna acceleration putok yargadi 1 second acceleration putok yargadi a is equal to kaino have the v square minus u square by 2 kari 2s so v square di kai tarni v square di c tarni 2gh 1 plus k square by r square tare and then minus the 0 ni ko u di 0 ni yare then the 2s ko so 2 what is s st kaino have the I can say h se s cos theta ni dana ko sorry s sin theta ne ba h is equal to here we know h is equal to s sin theta so aduna s di h by sin theta ne ba ko aduna h by sin theta la ne ba ko so adu ibataraga which is equal to kaino have the h ka cancel set kre 2 ga cancel set kre auna kaino have the z sin theta divided by harga 1 plus k square by r square. This is the acceleration yare ko and then mathang da let's find out the time taken. So a is equal to kaiba z by sin theta divided by 1 plus k square by r square hai tare ko sisi kitang chingkhat ke duga sigi si ai keno ni ko next class the pan ga duine ba sigi formula singji adugi ne sir na kitang keno ina lois now yare let's proceed ka aduga mathang da kai leire have the time taken ang puthoge kinematic equation nga tani ko time is equal to kaino v minus u by a natra so v di kaino v di asilere aduga kaidawa a na silere c ni g en thongna di kai tani kaidawa root over 2gh root over 1 plus k square by r square layena aduga kai ni yendiba a ni yendiba a di kaino z sin theta and mathakta na kai 1 plus k square by r square adurgadi kaidoni have the sigi aina kaino se sin theta ko h se aina s to thoksia s to thokudi nuai te ko aduna masi aina kaido sige have the can I write like this? Root over hierarchy z square by sine square theta harsu yaibako. Auna z square by sine square theta haramnina makada root achawam thamage. Root achawam thambata argadi c root siga haidi sida root square hierarchy kedwa amale morni aduna obviously here will be 1 plus k square by r square lerni ka. And then makada we have the z again see the 2 lerni ka, see the 2 lerni. And then see the z makada lemani kay z square ka z lemani. And then sine square theta z kay h by s never ka. Or I yes h by s tong kay nong loaning daw ka adugini adu ay targadi kay that kano to sige have to iwan ko. Okay, s loaning ready ay kano do regadi adi kay dorne h ka h by sine theta the s never ka on a 2s hydra 2s by h s by h by sine theta the s never ka, and then s by h yung tawa s by h yung tien theta tay here s by h tay chumbra in hai sa hai with the h by sine theta the s never ka h by sine theta the s never ana aduga muka makada muka sine theta lagi never ka ana again that's not good. So formula c karamba moigi standard formulas in a karamba na fagi have to ying ka 1 second. Is there any standard formula for this one? Z sine theta da dum thamana dum forever ka. So all right, so h by sine theta ka aduna si z ga ka creduga aduraga di sine square theta si kedoba z sine theta na thamana forever ka. 1 second ka aduna 2s by z sine theta si na quite far yeah. So here let's simply take it as let's remove the h ka h lautosi aduga sida ina dum sin theta hapasika sin theta yare. So the time taken t gi formula sina si lere ko noi si gyan adum keno to ngambra gyan ta ngambra ma'am tiyo no response. Keno to ngambra Lakshmi adum yari ba
Just
nati keno sida ne si
last second step की third चीज
kay haba
last second step की g square sin square theta लापगे root over g square sin square theta root over से काय दे लापन खंगोदे सा.
Oh okay sigi root over 0 ha
Hoy sir.
Okay. So hai ke ba sigi root over se asem di yaw deba sigi root over se yaw deba only z sin theta ka tang ne ba ko adu sir na ne si ga kak pa nungai na ba na root over ha pa di yung square ong to dra square root ka haidi root over si ga square sing ji kak na ga z sin theta dum ta dra
Oh sir.
tai ko adu ne ba adu si z ga z square ka ki matam na makha da z em le ho roi dra.
Hoy sir.
Aduga sin theta ama le hore and sin square theta ni na sin theta ama thamaga sin theta ama du di h by sin theta di kay na h by sin theta di kay oidu na s oidu ne ba ko h by sin theta from here h by sin theta is s yai ko adugi yani okay fine
Yan sir.
okay tarni bu ko atay di loin tar ba amarjit ta hobra say the boss tare bu ko okay fine nikhil yare ko nikhil cheta kumani asterisk tar ba Okay, tadre. Okay, fine. Tare ko. Anyway, so CC rolling motion ki formula. Tare ko. Okay, okay. So rolling motion ki formula is ahum zini. CC important oi, then CC is important oi acceleration and this time period is important oi ko. So formula ahum zi. No ina ne. See formula ahum zi. Kaya we have the again real exam no pekha the DC derived to lay ya pote ko. Ona. No ina combine to formula nixing niya matam the no C1 plus k square by r square mind the option grow C factor ramane C की factor जिना कदोनी है बता ये उन्हें नहीं कि velocity से चुम्ने पोट अमा जी frictionless surface हम द नांदर को मतम द और माजी पोट अमा free fall थादर को मतम द my final velocity is root over 2gs होइद्रा or root over 2gs होई बनेबा b square is equal to u square minus 2gs ni अदुना मसाइगी v दु कहीं ना द initial free fall ni ना 0 लग रहा है ना root over 2gs हम तारेबा अदुगी root over 2gs to दगी कितंग tapan doineba no 1 plus k square by r square na yen doineba kai no am matam maji roll torokoni na ko hay free fall makti natte dana aduna my velocity du kitang tapoidra aduna yen thu over aziki factor du da adai si gi sida ju ke du acceleration do faina frictionless surface am the pat nantra ko g sin theta ne acceleration do adu di oiro adi kitang khak less ora kane na g sin theta du da si sina yelo si factor jina gyan dai ko acha sumain to duna time period ta ju kai no habada 2s by z ne ba sai ko adu da ke do we have that time period to kitang matam do hena sanga ka doini na mathak to ina into to chaloba 1 plus k square by r square je yan dai ko habdi soina ke do ba body ama si free body ama si glide to ro ko do makha da nandharak ko do ko adu da z sin adu di 2s by z sin theta ta bane ba magi time period che ko adu gi du da khara hena matam ji sang doini na 1 plus k square by r square times hai ta oihan ga doine ba gyan tai ta de kanang ko
Tai,
mangsi
sir.
tai ko okay
Tai, sir.
maru ri se si formula derive to busi budi sir na to wi re hayeng exam da comment to ga kawroi dinu hai dune ba natra noi na hanjan hola ga budi kawroi so comment to recall to dinu hai the c factors in the karam kan divide to ni kam kan divide to ni kam kan into to ni have do adu khango time period oi matam ji hena chang ka do into to ba velocity tab tharak to in divide to ba acceleration to tab tharak to in divide to ba ko adugi potunida atai di general formula ne 2s by g sin theta is inclined plane am the pot am na frictionless surface am the nandrak pagi formula ne je si tarak pai formula ne je si tarak pai formula ne ko accelerator pai so anyway ngasi class si da local si ko ngasi gi de yam
Yes, sir.
okay thank you for the class ka have a good night thank you
Thank you, sir.
thank you